Okay, so this will be a video tutorial explaining a few of the common, maybe uncommon pitfalls that are involved with JavaScript. So our first example is array is not equal to array is equal to not array. What that basically means is if you look over here, we have an array and we're trying to say is equal to not array. But this somehow ends up being true. And so if we run this command, we can test that it does actually come out to be true. And so what we notice is that abstract equality operators convert both sides to numbers to compare them. So what JavaScript is actually doing is we're taking this expression and starting over here. So we're going to take this, compare it to positive array, and then positive of a negation of a array. So what this does is it turns it to 0 and then plus of negation, which is false. So 0 is equal to false, and this equals true. And so that's why an array is equal to not array. So our next example. So array is not equal to true, but not array is also not equal to true. So similarly, array is equal to false, but not array is also equal to false. So what that means is if you look here, true is equal to array, and this ends up being false. But if you think about that, true is equal to not array, that's also equal to false. So what it's actually doing is if you convert the true to a number, that gives us 1. And if we convert an array to a number, that it gives us 0. So 1 technically does not equal 0, so that's why we get false. But also, the negation of an array, that gives us false. So knowing that true is equal to 1, we know that true is not equal to false, and that's why we also get false. But now, if we try converting a false, or if we say false is equal to an array, this gives us false, and the array gives us 0. And so that's why they both give us 0 and 0, and that's why it becomes true for that. And same goes for the negation of an array, that equals false. And because false is equal to false, that equals true. And that's why these two give us true, and these two give us false. And we can just test it real quick. Oh, not that one. Okay, so we see false, false, true, true. Okay, so NaN is not an NaN. So what that basically means is that when we do here, we try getting the strict explicit comparison, and you would think that because they're the same thing that they would be true, but this is actually not the case. So we can actually run that example here, and we notice that it gives us false right there. And so the reason for this is that if we go back to the definition of a strict equality comparison, we can see that if type X is different from type Y, then return false. But it's also saying if type X is a number, then if X is NaN, return false. And if Y is NaN, also return false. And so that's why we end up getting false for this one. Okay. So object is and the explicit comparison have some weird cases. So what object is basically it determines if two values have the same value or not. And it works similar to the explicit operator, but there are some few weird cases that we'll look into. So we'll look at the object is of NaN and NaN. And so this ends up being true. But if we look at the explicit comparison like we did in the last example, this equals false. This is one pitfall that some people may fall into. So another one we see is the object of -0 and 0. So technically they are strictly equal but not the same value, and so that's why we get false here, and then we get this equality as true. And so same thing here. So NaN and 0 divided by 0, this ends up being true. but if you explicitly compare them, they equal false. And so in JavaScript, nan and nan are the same values, but they're not strictly equal. And so similarly, -0 and 0 are strictly equal, but they're not the same value. And so we can quickly do a little demo here. And you see, if we compare them, true for the first one, false for the second one, false for the third one, false, true for the fourth one, true for the fifth one, and false for the sixth one. And that all matches up right there. Okay, so going to the fifth example. So minimum value is actually greater than 0. So number.min value is the smallest number, which is greater than 0. And so we see that here. That minimum value is greater than 0, and that equals true. And I can quickly show that as an example. And so as we ran that code, it actually comes out to being true. And so this is because min value is actually equal to 5 exponent to the power of -324, which is the smallest positive number that can be represented within a float precision. And so if you want to fix this, the technical smallest value would actually be number.-infinity, although this is not technically a numeric value in a strict sense. So I go to our next example. So adding arrays. So adding arrays doesn't really work how you think it is. So concatenating two arrays doesn't work as expected. And so when you try basically doing 1, 2, 3 in an array plus 4, 5, 6, it actually gives you 1, 2, 34, and then 5, 6. And so I can show the quick example to prove that it actually is that. And it shows right there as that's the value. And so what's actually happening here is that it basically wants to take the first one, call a toString of that, which returns this, and then it takes the plus of the toString of the next one and concatenates it. So we get the first one being 1, 2, 3, and 4, 5, 6. So when we concatenate them together or do the adding, that's concatenating, we get 1, 2, 34, and then 5, 6. And so that's like a weird phenomenon that happens in JavaScript that a lot of people may get confused about, but that's just something to know. And going to example number 7. So precision of 0.1 plus 0.2. So theoretically, the average user would think that this would equal to 0.3. But here we can see a console log of 0.1 plus 0.2 is equal to 0.3, and then 0, 0, 0, so amount total ends in 4. And we have the next line saying 0.1 plus 0.2 explicitly equal to 0.3. And this ends up being false. And you may wonder why. And so this is actually a common thing that's actually found on a lot of languages that handle this operation. So the reason behind this is that the constants 0.2 and 0.3 will be approximated to their true values. It happens that the closest double to 0.2 is larger than the rational number 0.2, but that closest double to 0.3 is actually smaller than the rational number 0.3. So the sum of 0.1 plus and 0.2 ends up being larger than the rational number 0.3, and hence disregarding the constant in the code. And so that's how you get this. And so I can do a quick demo here. So this is 7. And so as you can see, it's right there like that. And going to the next example. So some funny math that we'll actually notice in JavaScript, or it's mainly JavaScript, is these for operations. So the first one being is 3 minus 1. A logical person would guess it to be 2, and that's correct. And 3 plus 1 is equal to 4, which is correct. And then the string value of 3 minus 1. This might be a little bit confusing, but you might guess 2, and it should be correct. Now we get the string value of 3 plus 1. You would think if it follows the same rules as the string of 3 minus 1, you'd get 2. So doing the same logic, you'd do 3 plus 1, and you'd guess it to be 4. However, this is not the case. Whenever you do addition with a string, you would actually concatenate them. And so the easiest way to understand how this works is to look at this little chart right here, or table. So if we have a number plus a number, we're going to add it. If we're going to do a Boolean plus a number, we're going to also add it. If we do Boolean plus Boolean, we're going to do addition. But when we do string plus number, we're going to concatenate them. String plus Boolean, we're going to concatenate them. And string plus string, obviously, you're going to concatenate them. And so to do a little test of this, we're going to do that. And as you can see, we get 2, 4, 2, and 31, where these are all numbers, and this is going to be a string. So now moving on to the next example. So default behavior of array.prototype.sort. So imagine you need to sort an array of numbers. So we have 10, 1, and 3. And so we do the sort command. You would think that it would logically do 1, 3, 10. However, in this case, it's only doing 1, 10, 3. And this is because the default sorter is built upon converting the elements into strings, then comparing their sequences of the UTF-16 code unit values. But if you'd like to fix this and sort it normally, you can actually do add in a function, an honest function inside, where it takes the A and the B value and then does the subtraction to use that. And so it would now result to the correct how you'd want it to be, so 1, 3, 10. And so I can do a quick example of that. And you can actually test that the first one gives you 1, 10, 3, and the second gives you 1, 3, 10. And so to our last example. So tricky arrow functions. So let's say we have a function, or let f be a function which returns the value of 10. And we want to output the value of f, and that you would properly guess as 10, and you'd be correct. However, when you do a so in our case, let g be a function which returns the curly brackets. And so you logically think that when you do the same thing, that it would return the curly brackets. However, in this case, it does undefined. And the reason for this is that the return for the curly brackets doesn't work is because the reason it doesn't is because the curly brackets is part of the syntax for the arrow function. So in that case, g will return undefined. But we can quickly solve this by putting it inside, directly inside the arrow functions by enclosing the return value with brackets. So which means putting in the parentheses, and when you do the same function, the same setup, you would get the curly brackets as the returning. And so I can do a quick demo of that. And there we go. So it gets up being 10, undefined, and then the proper curly brackets. And that's going to be the top 10 pitfalls that a lot of people fall into, and how to solve them, or why they happen, and how to go about using them. And thank you for watching.